Michio Kaku has claimed that the James Webb Space Telescope has observed 6 massive galaxies that scientists previously believed to be impossible because of his extraordinary commitment to the domains of material science. These evaluations might lead to fresh insights into our comprehension of the cosmos. This groundbreaking and forward-thinking discovery casts doubt on long-held beliefs regarding the formation and evolution of galaxies. For this reason, it is worthwhile to keep a lookout for these updates. The seriousness of these disclosures is highlighted by the confirmation of such a reputable expert. Michio Kaku is a physicist of American and Japanese descent who is considered an authority in quantum physics and classical exploratory material science. He is a fascinating figure in science. In contrast to certain scientists who are more conservative and doubtful, Kaku has shown openness to the remarkable findings of the James Webb Space Telescope project. His eagerness to welcome such findings and disseminate them to the general public demonstrates his dedication to expanding our knowledge of the cosmos. We are pleased that this renowned scientist has made the decision to speak out and openly disclose what is now undeniable. It's evident from the popular physicist's comments on the findings made by the James Webb Space Telescope that this feature has piqued his interest. He speaks with enthusiasm and an almost focused tone. Come discuss the ramifications of Michio Kaku disclosing these 6 massive galaxies. As a researcher, Kaku has always had the ability to consider novel theories. Though essential, Einstein's theories of relativity and Newton's laws cannot fully account for the complexity of the cosmos. He has demonstrated throughout his life that he is open to ideas that contradict the existing quo. Although many of his colleagues have not yet adopted this position, Kaku believes that the discoveries made by the new telescope have the potential to enhance the science of cosmology. Critics of quantum mechanics and proponents of the Big Bang have been alarmed and restless over this, but Kaku finds it amusing. 6 enormous galaxies that date back to the early cosmos have been found, according to the JWST. Though they created barely 200 to 700 million years after the Big Bang, each of these magnificent galaxies has more stars than our own Milky Way. These extraordinary galaxies have been dubbed universe breakers by the team of space scientists who made the finding because, if verified, they would fundamentally alter our perception of the cosmos. These findings have important ramifications since they imply that the early cosmos was far more robust and complex than previously believed. This place is out of place. The theory of creation indicates that the universe was chaotic following the original event. It took a very long time for the first solid objects to develop, and even longer for them to become dense enough to emit light. Complex structures such as galaxies were thought to originate considerably later. Some of the recently discovered galaxies are larger than the Milky Way, and their extreme brightness implies that they were probably producing a large number of new stars annually. Although stars occasionally arise in our galaxy, the exact date of the formation of the earliest galaxies is yet unknown. This has not yet been established by scientists. The sole certain aspect is that there may have initially been only one or a few stars, which would later come together to form larger structures. Eventually, dwarf galaxies would then nurture smaller cosmic frameworks that would change over time. It was believed that enormous and incredibly large galaxies could not have formed at that period, which begs the question of whether the universe is older than previously realized or if sophisticated celestial structures developed much earlier. Conservative science, which continues to identify problems with this concept, finds it difficult to accept this predicament. A number of physics-related fields have openly disagreed with this finding and raised doubts about potential inaccuracies in the age calculations. Kaku acknowledged this and stated, "Due to the influence of certain professionals, there are many models of outdated and false theories that obstinately survive." It wasn't until extensive investigation showed these theories' shortcomings that many of them were exposed. Therefore, the experimentalists who maintain the researchers' vigilance and awareness are crucial to any discipline, but physics in particular. In actuality, very little is known about the universe's true beginnings on Earth. This quote from Kaku emphasizes how crucial it is for the scientific method to involve ongoing experimentation and validation. Based on observations of the universe's expansion, the theory of creation was developed in 1927. Based on this information, it was determined that the universe started at a certain place and has been expanding ever since. People and scientists found it difficult to envision a universe having a beginning and an end at the time. Humans could not have imagined a cosmos that was boundless and extant and had existed from the beginning of time. Scientists are still having difficulty comprehending it. Even if these new findings contradict long-held beliefs about the Big Bang Theory, it is nevertheless important to take these ideas into account. Science has repeatedly demonstrated that, in addition to accepting some theories and findings, critical thinking and receptivity to new ideas are essential components of the scientific method. It was once believed, even when Einstein was a young man, that the planets and stars were fixed in space and that their particular configurations inhabited a definite area. But as we know now, everything in the universe is in motion. Stars travel at several kilometers per second inside their galaxies. Planets circle, and entire galaxies move quickly through space, the fate of which we are currently unable to determine. This extraordinary comprehension of the world calls into question long-held assumptions and emphasizes the necessity of ongoing research and evolution in scientific ideas. Scientists nowadays face the difficult task of accepting new information and realizing that hypotheses are not infallible until thoroughly investigated or supported by precise observation. The observation that galaxies are moving apart and that this distance is proportional to their distance from Earth gave rise to the theory of the Big Bang. Hubble's law, which is based on this discovery, postulated that the cosmos was expanding with time. Other cosmological patterns and factors like cosmic background radiation and the redshift of light from far-off galaxies seem to corroborate this notion. It's crucial to keep in mind, though, that those who once thought the Sun circled around the Earth and that the Earth was flat had observational data to support their theories up until more recent occurrences or developments in technology painted a more accurate image. Similar circumstances are present right now. Rather than confirming doubts about the Big Bang, scientists were hoping that the new James Webb Space Telescope would reveal these 6 seemingly inconceivable galaxies. This demonstrates how science is always changing, the need for scientists to be receptive to new findings and to re-evaluate established hypotheses in light of new information. The unexpected findings cast doubt on our understanding of the universe and force us to re-evaluate long-held cosmological theories. Redshift is a technique used by scientists to calculate different metrics related to the study of the universe. Redshift, sometimes referred to as the Doppler effect, is the term used to describe how light changes color as light sources and observers move in relation to one another. To comprehend this, picture yourself motionless and hearing the sound of an engine approaching you. The sound of the engine gets louder as it draws near. Nevertheless, the engine's sound varies when the vehicle passes you or pulls away. This is a result of how the sound waves alter while the car travels. This is also true with light. Light moves to bluer tones when it comes from a distant star or other light source closer to us, and to redder tones when it moves away. We refer to this phenomena as redshift. In order to measure redshift values for the study of the universe, physicists have translated them into rates and distances. It is important to remember, nevertheless, that even a tiny inaccuracy in these measures might have a big effects. We are now reviewing the previously employed measurement techniques. Whether the most recent findings about our cosmos are really the result of redshift errors, or if some scientists are just lying about the data needs to be taken into account. This is an issue that has to be carefully investigated, and the facts and research methodologies should be thoroughly reviewed. The fact that measurement methods are still being investigated and re-evaluated emphasizes how scientific research is constantly changing. Thank you so much for viewing the video. We remind you to post your questions in the comments section as usual. In order to help the video reach more people, please hit the like button, share it, and subscribe to the feed so you don't miss any more great videos. I appreciate you viewing, and I'll see you in the next one. By encouraging viewers to interact with the information, this call to action helps to create a community of inquisitive minds that are ready to learn about and comprehend the most recent scientific debates. The enormous distances and intricate celestial bodies of our cosmos continue to captivate and provide challenges for astronomers worldwide in their exploration efforts. Every discovery, from the earliest universe ideas to the most recent ones made possible by cutting-edge technology, alters our perception of the cosmos and pushes the limits of human knowledge. The genesis and evolution of galaxies are among the most important and enduring problems in cosmology. Galaxies resemble cities made of gas, dust, stars, and dark matter that are all pulled together by gravity. Comprehending the formation and evolution of galaxies is essential for solving cosmic riddles as well as validating or verifying pre-existing hypotheses, such as the hypothesis of the universe's beginning. According to the Big Bang Theory, which was put forth over a century ago, the universe started as a single, infinitely dense point and has been expanding ever since. The cosmic microwave background radiation, which is thought to be the surviving vestiges of the early universe's extreme heat and brightness, and observations of the universe's expansion gave rise to this theory. Nevertheless, a number of fundamental presumptions underlying the Big Bang Theory have been called into question by subsequent discoveries, especially those made by the James Webb Space Telescope. Thanks to its exceptional sensitivity and resolution, the JWST has found galaxies that seem far more massive and evolved than would be predicted for their age. 6 huge galaxies that date to a time when the universe was only 200 to 700 million years old, a tiny blip in its 13.8 billion-year history, are part of one such discovery. The research team dubbed these galaxies universe breakers because of how massive and bright they are already at such a young cosmic age, defying current theory. The finding of these galaxies defies accepted theories of galaxy formation and poses fascinating issues regarding the quick evolution of the early universe. Current theories state that galaxies developed gradually over billions of years by the accretion of stars and gas and the merging of smaller formations. The fact that these large galaxies exist at such an early time in cosmic history points to a potentially speedier and far more complex process of galaxy evolution than previously believed. The revelation also emphasizes how important technology breakthroughs have been in changing our perception of the universe. Astronomers have been able to discover previously undiscovered facets of the early evolution of the cosmos because to the JWST's capacity to look farther into space and gather dim light from far-off galaxies. These studies shed important light on the circumstances and mechanisms controlling galaxy formation in the early cosmos. These findings have consequences that go beyond cosmology. They force researchers to re-examine and improve current cosmological models in order to more fully explain the observed complexity and diversity of galaxies over cosmic time. They also highlight how scientific knowledge is dynamic and ever-evolving, with new discoveries having the potential to challenge preconceived notions and pave the way for fresh lines of inquiry. Research on galaxy formation is still active and expanding as astronomers examine and interpret data from JWST and other telescopes. With every new finding, we get closer to solving the puzzles of our cosmic origins and comprehending the fundamental mechanisms that have shaped the universe as we know it. In conclusion, even while the finding of these 6 huge galaxies casts doubt on our existing theories about how galaxies form and the early universe came to be, it also marks a significant turning point in our quest to understand the universe. Such findings broaden our curiosity with the vast and complex tapestry of the universe and set the path for future scientific triumphs by pushing the frontiers of known knowledge.